is take a regular piece of printer paper and draw it or divide it up into 8 sections. So we take a sheet of notebook paper and divide it into 8 sections, which means you divide it. You don't do that, that's for sure. There. And you divide it down the middle, and then divide it like so. Now you don't have to divide it by lines. You can just draw 2 on 1. It doesn't have to be 8. You can draw it as big or as small as you want it. And in each one of the blocks, you draw a normal curve. Well, a whole lot better than this. But you draw it, and you draw the mean bar and the 2 standard deviations. And then you do the same thing over here, and then you run about 20 copies of it. Now, I would suggest you do that, because you're going to be drawing each problem you do in this section. You're going to be drawing a picture of a normal distribution, and you're going to get tired of drawing it. Okay, so this is the first assignment I would do in 7 point whatever we're doing, 7.2 or whatever. Okay, draw one piece of paper. All you got to do is one piece and copy it like 20 times. 90% of you, no, 70% of you will do that. Another 30%, well, the other 20% will complain, and then 10% that don't even do either one, they'll just not do either one. Not do the problems either. Okay? So make sure you do that. That's up to you. All right? Now, under the curve, you have what we call the area. And the area under the normal distribution looks like so. The area under the curve is 1. The mean represents the what? The middle, central tendency, center. Sometimes it's not the center, but there's the mean. And then, of course, you put your standard deviations here and here. Now, we're only concerned with 2 standard deviations, because 2 standard deviations is what? What's within 2 standard deviations? I'm sorry, what? No, normality. In other words, 95% of the population falls between what? 2 standard deviations. Empirical rule. Write down the empirical rule on this page. So in 7.2, in the first part of 7.2, I don't know how this book does it, but your mean is going to be equal to 0, and your standard deviation is going to be equal to 1. That's in the first part of the book, the section. So here I'm going to put 0, 1, 2, -1, and -2. So these are z-scores. Z-score is equal to x minus x bar over standard deviation, or x minus mu over standard deviation. Doesn't matter which one you use, they're still both the same. That's how you find a z-score. And there's one other rule, or one other equation that you use in this section, and that is x is equal to Oz plus mu. Now, besides these two things, you need to also remember the empirical rule. You've got to realize that what represents the left side of this mark right here, well, that's supposed to be the center, so this is 50%. Well, this is 75%. And this is pretty much 97.5% or whatever it comes out to be. So you need to kind of read it like a gas tank. This is pretty much empty. This is a quarter full. This is what? Half full. This is 3/4 half full, or 3/4 full, and this is full pretty much. And you can use the empirical rule to do that. Now, all of this is based on percentages. Okay? We'll write it down here at the bottom. Area is going to ask for the area. Everything in this section is area. Area, another word for area, is percentage. Okay? Another word for percentage and area is probability. So you may have several different questions in this section, and they may ask for the area, they may ask for the probability, they may ask for the percentage. Whatever they ask for, those three things are the same thing. Now, either you're going to be given the area. If you're given the area, then you're going to find the number. Find z. That's one type problem in this section. Another type problem, given z, you find the what? You find the area. Okay? So, make you a sheet. Make you a sheet that has this right here. Notice I didn't put the numbers. Those are going to change when you get in the second part of 7.2. Okay, so you don't want to put -2, -1, 0, 1, and 2 on all your drawings. Just leave that blank. The second thing that's important is that the first part of 7.2, mean and standard deviation are going to be 0 and 1. The two equations you're going to use in chapter 7 is this equation and these, well, this equation is the same equation, it's just different parameters. One means sample, the other means population. The other thing you need to remember is that in this section, or this part of the book, these three words mean the same thing. So if they ask for area, they're really asking for the probability. Or if they ask for the probability, they really ask for the area. And then the last thing is the two type questions you're going to have in this section is given the area, find z, and given z, find the area, or the probability, whatever you want to call it. Now, that's probably what they go into with the first part of the section. Let's look and see. And then we need to go into the z-scores. Normal curve, plus or minus standard deviation. We talked about that. There's your empirical rule right there on page 332. They're reviewing that over that for you. They're showing you what a curve looks like. I think y'all know what a curve looks like. There's the area under the curve. So you can put that as page 334. Area under a curve is the probability. Yeah, that's 7.1. I didn't know they were going to do all that in 7.1. In 7.2 or whatever section's next. I need the z-table. That's what I need. Okay, there's your z-score. Now we're getting into it. There's your z-score. X minus mu over standard deviation, or X minus X bar over standard deviation. S. The reason it's like this is because when you're working with area under a curve, it's usually done in population. And that's why they're using X minus mu over sigma. I know some of y'all have seen this before, and I'm sorry it's so boring, but all right, here's the z-table. Here's an example of the z-table. The z-table is in the back of your book. If you have a book, you can go to Google and type in whatever the name of this book is and what edition it is and put z-table, and it'll pull it up. You can print it off. All right. Now, one thing I like to tell students, and when talking about this section of math, is that I don't know what I'm doing. Is that if you're talking about two digits, two significant digits, meaning 2 decimal points, if they give you a number and it's 2 decimal points, that's a z-score. Okay? And this is just something I tell students, and it kind of helps because you don't know what you got. If you have 2 decimal points, if you start off the problem with 2 decimal points, you're starting it off with a what? A z-score. If you have 4 decimal points, you're starting off with a what? Well, what's the only other thing? Area. Good. So if you're reading the problem and they give you, an area of 80% or 0.8000 or something like that, then you know it's area and you got to find the z-score. If they give you the decimal point, 2.22, then they're giving you a z-score, you got to find the what? Area. So how do you use the z-score? Well, the z-table is right here. Well, this is the z-table. It's part of the z-table. I'm going to blow that up for you. Z-table consists of 2 pages. Positive z-score and what do you think? What do you think the positive z-scores are going to be on? The right side of the mean. Negative z-scores are going to be on the left side of the mean. So you got 2 pages that cover both. Also, the z-score gives you the area under the curve to the left of your score. What does that mean? Well, here's your score right here, 120. See that? That mark right there? Okay, if I look to the left of 120, I got to change it into a z-score first. That's the area that the table will give me. The z-table will give me this area right here. It's designed to give you the area to the left. So you need to write that down as far as z-score. Area, or z-table. Area to the left of your score. So if you ever need to find the area to the right, which means above, greater than, scores above 120, then that would be the right-hand side is equal to 1 minus the left-hand side. Now, the only time you need to know the right-hand side is when it asks for things that says greater than, more than, score greater than 120. But if it asks for less than 120, up to 120, or scores below 120, then you're dealing with the left-hand side, which is what the table gives you. How do you read it? Well, first of all, 120 is not even on this map, okay? So what do? Well, you turn it into a z-score. 120 is your z-score. 100 is your, what is 100? It's in the middle. What is the middle? Mean. And then what's the difference between 100 and 115? So that means your standard deviation is what? So z-score is equal to 120 minus 100 over 15. And what is 120 minus 100? 20. And 20 over 15 is equal to what? 4 over 3, which is 1 point what? 1.3? 1.33? So we got to find a z-score of 1.33. Now, if we are given the z-score, which we are given, because we're given the stuff to find the z-score, then that means we got to find the what? The area. So you look up 1.3 right here and go across until you get to 0.03. What's $1.30 plus 3 cents? $1.33, right? And that's what you want. $1.33 gives you a 4-digit number of 0.9082. And that's your area. 0.9082. So the probability of a score being less than 120 is about 91%. And that's how you do the area under a curve. It's real simple. That's all there is to it. Who's got a question? We'll do another 5,000. Anybody got a question on this one? Now, you can also find using the calculator. I'll show you how to do that when the time comes. All right, let's try another one. See if we can find one that doesn't have a bunch of explanation. Oh, wait. I'll just make one up. How about that? All right. Let's go with a mean of 100 and a standard deviation of 15, just like when we did. And I want to know the area, or not the area, well, yeah, probability. I like to use probability, but we'll use area. What is the probability of having a score less than 80? And I'll bring in that z-table so you can use it. Well, I don't know if I'll be able to or not, but go ahead, I'll find a z-score. Let me just pull up. While y'all doing that, I'll pull up a z-table. Who wrote this book? Anybody got a book with them? Who wrote it?
Michael Sullivan.
Sullivan, okay. What edition is it? Sullivan. What edition? Does it say on the front or back, or down at the bottom? On the front page, it doesn't say anything. No, on the front cover, it should say on the bottom.
Fourth edition.
Fourth edition. What's the name of the book? Sullivan.
Fundamentals of Statistics.
Of Statistics. Fourth edition, z-table. Really? I should pull up Triola, it's a lot easier to find. Triola. Z-table. There. It's a lot easier. All right, so 100 or 80 z-score is equal to 80 minus 100 over 15. Well, that's 100, 115, 130, what is this, 80? And, no, that wouldn't be 80, it would be what, 85? No sneezing in class. And 70. Now, take your handy dandy red marker or blue marker, and 80 would be right about here, right? Now the table is going to give you this right here. So that means less than or greater than. And that's what it wants. It says I asked for less than 80. So here's your 80, but the problem is the 80 is not a z-score, so you have to change it. 80 minus 100 is equal to negative 20. over 15, which is equal to negative 1.33. So now you got your z-score. Go over to your handy-dandy z-score table, which I pulled up Triola because I tried to pull up the other one and it gave me the runaround, so I said to heck with it. So I pulled up Triola, which is the book we used last semester. And you just, that's positive z-score. So you go over to the negative z-score table, which is the next page, and you look up negative 1.33. Negative 1.3, 0, 1, 2, 3. 0.0918. 0.0918. So what is 0.0918? 0.0918 is this blue area right here. So the area that's below the score of 120 is 0.0918. So if you took this test, what is the probability that your test would be below 80? You got a 9% chance that it's going to be below 80. Yes, sir.
Now, how would we get, like, what I did was I got the 0.0198, I did it from 1. Like, is that
Well, that's for the right-hand
is that
side.
greater?
If you wanted the right-hand side, yeah. The right-hand side is over here, and that would be greater than 80, and that would be 1 minus 0.0918. What's so funny?
I'm very confused on why you went over 30. I know you went down below 0.3, but
I'm trying to get there. All right, here is negative 1.3. Right there. All right, you don't want 1.3, you want 1.33. So the first column is 0. This is 1.30 right here. 1.31, 1.32, 1.33. So that's your area. That help? Now, that one's pretty simple. What if I asked you to go above? Well, then the above would be, what is the probability above? I'll just go ahead and do one. Let's do this, since you don't have to write another one. Sorry. How about score? Give me the probability or the area above 120. Area above 120. So what's the first thing you got to do to get the green area? You got to change 120 into what? A z-score. So the z-score for 120 is going to be equal to 120 minus 100
Incoming transmission.
over 15. And that's going to be 20 over 15, which comes out to be, a while ago we did the same thing. Didn't mean to do the same thing over 1.33. Now the problem is that you're going to go to 1.33 in the z-table and you're going to write down that number and it's going to be wrong.
You have a work email.
God almighty. You know, people don't respect that you got a job. There. Okay, 1.33. Now, you need to have, the table's going to give you the left-hand side of this mark right here. That's not going to help you. You got to take, since this is greater than, right here, this is greater than, you've got to do right-hand side is equal to 1 minus the left-hand side. So, the table is going to give you this area right here. Go to the table. It's a positive z-score of 1.33. So that's 1.3, 0, 1, 2, 3, 0.9082. But that 0.9082 is not what you want. That's the left-hand side. So to get this green area, we got to take point or 1 and minus point, whatever I said, 9802.
908.
Thank you. 9082, and that's going to give us 0.0918, and that is the area there. Now a lot of people say, well, why don't you just use the negative? You can't start doing that, because if you start doing that, you're going to get even more confused when we do one in between. So just do what I tell you. It's a whole lot easier if you do it this way. It's not confusing. Now, what if I give you the same number up here, and I want you to find an area between? I want you to draw a picture. Mean is equal to 100. And the standard deviation is equal to 15. And I want you to find the area between 70 and 100. Now, the main thing I want you to do here is draw a picture. I'm not thinking you're going to do the whole thing unless you've had this material before, and if you have, that's great. But some of you that haven't had this material before, what I want you to do is just actually draw a picture using the curve. And then after you get that, you can meditate if you want to. All right, 100, 115, 130, negative, or sorry, 85, and 70. Now you could do it with the empirical rule and say that, well, that's 50 right here. 50 minus 2.5 is going to be like 47.5. You could do it by the empirical rule, but the empirical rule is not accurate enough. And it may come out the same, it may not. But you've got to take this area, which is 100, this area right here. Thank you for messing that up, Hubert. Oh well. Let's go into mess up everything mode. Okay, you get the point. The whole area in green is the whole left-hand side that goes up to 100. Okay? But we don't want what goes up to 100. We want between 70 and 100. So we need to shave off this area right here. If you shave off the red area from the big green area, then you're left with the blue area. And that's what you want. So when you're talking about between, this is between, you got to take the smaller area away from the what? The larger area, yes. Okay? So we got to change 100 into a z-score, and we got to change 70 into a z-score, find the area for both, and then subtract. So 100 minus 100 over 15 is 0. Okay? So I got that for you. I did that one for you. Now let's do 70. 70 minus 100 is negative 30. Over 15 is negative 2. Is that what y'all got? All right. So now we go to the handy-dandy z-table. And go to the negative screen because that's basically where we're going. And they have 0 right here is 0.5. So you're going to take 0.5 and we're going to subtract negative 2, which is 0.0228. So I'm going to go back to my screen. 0.228. 0.0228. And that's going to be in blue. No, in green, sorry. The big area is 0.5000, and we're going to subtract the red, which is 0.0228. And that's going to be the blue area, which is 0.488182. Somebody help me out. Check my math. Did that come out right? 0.47772. Thank you. So what is the probability that your score is going to be between 70 and 100? 47%. 47.72%. Or 0.47772. 7.2. Now this is important because if you get a question and it asks for the area in between something, you're going to have to subtract the small area from the big area. You need to remember this problem. Okay? Comprende? All right.